Hey, hi. My name is Young Park. I'm the entomologist in the UAPB Department of Agriculture, and I'm going to introduce you today about the bees, honeybees. Okay, this is actually the body, and we have the top cover, and we have the inner cover like this, and actually this cover is like an outside cover that's going to prevent the rain and those kind of stuff, and this one is kind of insulation. And so most honeybees, they have to maintain about 95 degrees inside in here, and inside here what you can expect, and there is the egg and the early larva and old larva, and become pupate and ready to emerge. And they emerge. As soon as they emerge, and nursing become and feeding him. And this is a male bees and this is female bees. How do I know? And eye size. The male bees have a larger size of eyes, and the female bees have a smaller. Okay, and you can. And they're expecting the bees like that, and then they also exchanging the food each other through the tongue. That's what we call the trophallaxis, and that is a typical insects. And you can expect that this one is a comb. This is cross section of the side way. You can see the both way, and here is kind of specific, unique. The space, this is what we call the bee space. That is about 3/8 inches or 0.95 millimeter. And that is the two bees can walk through. So that is very important. If it has a wider, they will make extending the comb, will making problems, okay? And major thing is the queen bees, okay? Queen bee here, and they surrounded nurse bee. They just serving her, and she is laying deposit eggs inside the cell, okay? And so that is all about the honeybees. And if you have questions, let me know. And Department of Agriculture, and my name is Young Park. Thank you.
Hi, I'm Kathy Knierim with the U.S. Geological Survey, and we are at one of our monitoring sites where we measure water levels in the Mississippi River Valley alluvial aquifer. This actually shows a cross-section of where we're standing with the aquifer. There is a clay cap, and then here represents the layers of sand that water is withdrawn from in this whole area of eastern Arkansas, and water is mostly used for irrigation for farms. The River Valley alluvial aquifer is a very important aquifer for that reason. It's a very productive aquifer. But the reason that we keep track of it with these monitoring wells, which are shown here, we have this box that keeps our battery and equipment dry, and then this actually represents the well that's drilled into the ground, and here's showing where the water level is in the aquifer. So we have a transducer down here that keeps track of how high that water level is, and it's a continuous monitor, so we can look at the water levels through the year and then over time. So this is a graph showing at this exact well what our water levels look like, either with depth to the water level, how far down it is, or you can look at it as an elevation, how far up it is above a certain level like sea level. And because of the continuous monitoring, we know that there's not only a trend downwards through time because of the pumping that's going on and the withdrawals for irrigation, but there's also a seasonal component. As you have irrigation, you're increasing your groundwater withdrawals during the summer when it's dry and our farmers are growing various crops, and so you see this drop in water level, and then you see a rebound as you get recharge, less pumping, and that continues over the years. But overall, there's a general decline in water levels because of the irrigation withdrawals and because of how much we need these groundwater resources. So the monitors help us keep track of this. We have more continuous monitors throughout the state, and we also take static water levels, which means we go to a well that doesn't have this equipment in it, and we use a tape to get a idea of how far down the water is all throughout the eastern Arkansas. So this shows in eastern Arkansas here with the Mississippi River Valley alluvial aquifer, the same one I've been talking about, what is the surface of the water level for a snapshot in time. And we do this throughout the years so we can see how these maps change, and these are called potentiometric surface maps, and it represents that water elevation from a single point in time, or as I talked about over here, in certain wells where we have these continuous monitors. And it's important for us to keep track of this so we know how the water levels are trending, so we have access to this valuable resource in the future.
My name is Bob Scott. I'm an extension weed specialist with the University of Arkansas, and I'm here today at the UAPB field day. Today I'm here to talk about the research that we do here on the UAPB farm. Primarily, we use this site for rice weed control work. We also do some soybean weed control work. One of the things that I am going to discuss today is weed competition and some of the serious issues that are facing farmers today in both rice and soybeans. As you look at this hemp sesbania plant over here to my left, you can see it's well over 6 feet tall, 7 feet tall. It looks very intimidating. Truth be told, this weed is very easy to control in rice, and so sometimes looks can be deceiving. More important to rice producers these days are the three weeds that I have in this bucket over here to my right. We've got barnyard grass, we've got yellow nut sedge, and we've also got Amazon or tighthead sprangletop. Now, the reason these three weeds are so important right now in rice is because they've all developed resistance to various herbicides, most notably barnyard grass, which is now resistant to at least 4 different classes of rice chemistry. Recently, we've had ALS resistance or resistance to the herbicide permit develop in nut sedge, which has been very troubling. And we've also had resistance to some of the herbicides that we use to control the Amazon sprangletop later in the season. Out here on the research farm, we're currently looking at least 4 different classes of chemistry for rice, 4 new herbicides for rice, and they all have activity on these very troublesome and resistant weeds. The other topic that we're discussing at this stop is soybean weed control. Over here to my far right, we've got the most troubling weed in Arkansas today in terms of weed control in soybean production, and this is Palmer pigweed or Palmer amaranth. Now, this pigweed has developed resistance to 4 different classes of chemistry in the state of Arkansas, making it very difficult to control. So one of the things that we're going to talk about on this stop is a relatively new technology called Liberty Link. Liberty Link is sort of bridging the gap between Roundup Ready soybeans and the newer technology that you may have heard about, such as Extend and Enlist and HPPD tolerant soybeans that are coming in the future. Liberty is a very good option for controlling glyphosate resistant Palmer pigweed, and this year in Arkansas we saw over half the acres of soybeans grown to Liberty Link beans, and it's primarily in response to this weed right here, Palmer pigweed. For more information on weed control, you can check out our publication, which is the MP44. It contains all of our weed control recommendations for all crops and is available on our website at www.uaex.edu.
Okay, I'm Dave Bowling with the Arkansas Forestry Commission, and we've had over a 20-year partnership with UAPB Farms. And what we've done at UAPB Farm is occupy about 42 acres of their property for testing of pine and hardwoods. And you can see on the chart here we have 5 pine tests that occupy about 13 acres, almost 12,000 trees, and then 6 hardwood tests that occupy almost 29 acres with 12,500 trees. So it's 41.84 total acres that we occupy here at UAPB Farm. And this is a map that shows the outline of the tests, and all of the pine tests are numbered 1 through 5 and say pine, and the hardwood tests are HW 1 through 6. The primary objective in any genetics program is to provide a better quality product for the end consumer. In our case with timber, we deal mostly with private non-industrial landowners in Arkansas. So our objective is to be able to increase the probability of a good profitable crop for a landowner. And what we've been able to do in tree improvement, short version of the story, is to take a Woods Run seedling as our base or our check lot. and we test against the check lot or Woods Run for our genetic gain. The best family that we produce at our Balcom nursery now has 51% genetic gain. So that means that if you planted 100 acres of timber that's unimproved, and let's say you're on a 30-year rotation. That used to be the norm. In 30 years, you harvest 100 acres worth of timber. If you plant 51% genetically improved on that same 100 acres in 30 years, you would harvest 151 acres worth of timber. So you can see that's major advantage for a landowner and money in their pocket. So that's the purpose for the program. And that's why we have set up the tests at UAPB Farm that we have, is to be able to improve the quality of timber for our landowners. And this is the largest single test that we have. We have 52 active tests in the state across all parts of Arkansas. And UAPB Farm occupies 11 of those tests. So this is the largest single plot that we have for our forestry testing.
Hello everyone, my name is Ernest Bradley. I am here to talk to you about organic gardening. Organic gardening meaning that there are no synthetic products used in whatever production you're trying to grow, whether it's fruit, vegetables, or whatnot. There are no organic substance used at all. What we have here, we have a variety plot, a demonstration plot that consists of 4 different crops. The first crop is, well, this crop right here is sun hemp, and that is part of the control crop, not necessarily the part of the plot itself. But the first beginning of the plot is right here. We're looking at sweet potatoes. On the sweet potatoes, there is all organic material used on it. We had some southern peas. Again, that was all organic material. Watermelon, and then sweet corn, and then the plot starts all over again. And what we notice is the difference in the yields on different practices. Organic meaning that not necessarily more, but at least a better quality. When you taste a tomato that's grown with synthetic products and insecticides and so forth, then it's kind of mediocre. But when you get a real organic tomato that was grown organically, you can tell that there's a big difference in the taste. So there's a place for organic crops in Arkansas, but there's a lot of procedure you have to go through to be certified organic. You can go to the extension webpage and find out what those requirements are. Sometimes they're a little bit dissuading to an effect, but it is well worth your interest if you decided to do that.
Good morning. I'm John Lee. I'm with the Natural Resources Conservation Service. I work as the state agronomist for the state of Arkansas, and I was asked to give a demonstration on farmers' management decisions and their impact on soil health. And what we're going to do is use the rainfall simulator to demonstrate the impact of different decisions based on how a farmer manages the soils on their field. What we have over here are different soil types up under different management systems. This first soil is a lowering silt loam soil type. It's managed up under conventional tillage means. There's no residue that's left on the soil surface. And next to it, we just like to use a reference point. It's the same soil type that has not been disturbed since 1999, has a switchgrass cover on it. Beside it is another soil that has been managed under no-till conditions. It has cover crops on it where the farmer manages that cover crop for high residue. The one beside it is a soil that has been managed up under conventional means with no crop rotation. Only soybeans are raised on this soil. And beside it, we have another soil that's managed up under no-till conditions with low residue. The farmer actually terminates the cover crop before the residue is allowed to mature. We're going to turn the rainfall simulator on, and let's just see what happens here. One of the things that we want to keep in mind based on how we manage our fields, whenever we are having rainfall events, there are 2 things that either are going to happen. Number one, we're either going to be able to capture that rainfall for crop production, meaning that water is allowed to move into the soil profile, or that water may simply run off the soil surface into some receiving ditch. And if we notice, the first thing that we can see is that there is accumulation of water running off the soil surface on the soil that has been disturbed, that is being managed up under conventional tillage means. We notice that next to this soil, where the soil has not been disturbed, we don't see any runoff. But when we look at the soil type that is being raised for crop production with cover crops and high residue, we also notice that there is no runoff on this soil. Virtually very little water is being allowed to run off. The soil next to it is a soil that has been managed up under rotational means, non-rotational means, where they're raising soybeans only under conventional tillage. And once again, we see that there's a lot of runoff. The soil next to it is one that has been raised up under no-till conditions, has some residue on the surface, but certainly is still allowing for water to run off the soil surface, as well as capture some of that water due to the fact that I'm for sure there is some organic matter that has been accumulating in that soil. Now what we're going to do is turn the water off and see what actually was allowed to enter into the soil. This first sample, no water was allowed to enter into the soil. So a farmer who was raising crops on this particular field, the first thing is the water that was given to them in the form of free rainfall water that could have been used for irrigation, we didn't get any. That water was simply running off the soil surface into a ditch. But let's look at the farm that raises crops in a rotation with corn and soybeans with high residue cover crops. And let's look at what happens here. This farmer actually was able to capture quite a bit of rainwater. So what this does is over time, it reduces the number of times that farmer has to turn an irrigation well on to water a crop. So when we have a farmer who can reduce the number of times that they're running their well, the first thing we're doing is helping to improve and protect our groundwater resources, but it also helps that farmer to save on the bottom line because they're reducing the time that they have to turn the well on. That reduces input costs in the terms of utilities for running a well. This same farmer has reduced the amount of fertilizer by 50 units per acre, but yet their yields haven't suffered. He's still averaging somewhere in the neighborhood of 240 bushels of corn per acre with very little water running off that soil surface. Once again, our conventional soil has a lot of water that ran off the soil surface. So we don't have a lot of water that was allowed to enter into the soil. So once again, this farmer, if they're raising dryland crops, have a risk of those beans being going into some kind of stress due to lack of moisture, or if they're irrigating, they're going to be turning the well on just to get water on that field. Although this field is managed up under no-till conditions, without leaving the high residue on the surface, we still have some water running off, but we also had a little water that was allowed to enter into the soil. Now, one of the benefits that I've seen with farmers who are moving to no-till with cover crops, not only are they able to reduce the amount of input, but also we've seen those same farmers see an increase in yield. So by being able to reduce the amount of fertilizer that's necessary for that crop, also being able to reduce the number of times that they're having to turn an irrigation well on, they're saving money, but also some of these farms are getting a higher yield, so they're not losing money. And in fact, they're making more money by reducing the amount of times that they disturb their soil. This particular farm has been able to extend the irrigation cycles out on corn from irrigating every 7 days to every 14 days. So right there, it sounds like that person should be able to cut their watering cost in half just by mere fact that they're only putting water on that field half the times that a farmer who's conventionally tilling a soil and raising corn on it would have to.
This area here is the establishment of our native tall prairie grass seed, established in 1999 when the wetland project entered into partnership with the Biometer Irrigation Project and the Memphis District Corps of Engineers. Right here we've got switchgrass, and we got Indian grass, we've got big blue stem grass and little blue stem grass. We've established over 100 acres on this site, and the establishment of this grass is in order is to use seed, gather seed, and plant it on canal banks, reservoirs, pipelines, any constructed areas where the ground has been torn up and there's some sort of erosion that might occur. We've got about 100 acres planted, and in this project we will harvest the seed, and then also harvest hay. And if you can look to your west down there, you see those rows of bales rolled up down there. The Corps of Engineers will come and get those and take the seed and plant it and use that, grind that hay up for mulch. This grass, we'll harvest it probably in sometime September, October. Of course, the little blue stem comes off in November. And it grows the switchgrass grow about 8 feet tall, 7 to 8 feet tall. It makes a good wildlife habitat used by deer, rabbit, quail. Quail love it. And songbirds. Songbirds go out there during the summer in their nests. Very, very good erosion control. We plan to put in some more blue stem sometime here this next year. And the Corps of Engineers would come in and they would take these seeds and take them and plant them.
All right, good morning, everybody. My name is Lee Anderson. I'm the staff chair in Jefferson County for the Cooperative Extension Service. Today I'm taking the place of Stephen Walker. I was notified like Tuesday that Mr. Walker got sick, and they asked me to come present you guys this soybean demonstration plot they have here in Lone Oak. All right, soybean herbicide demonstration. The names are 11F Pioneer, F7T, 36RR, and the other variety is 11C Progeny 4930 Liberty Link. The planting dates for these soybeans was 6/9/16 and 6/13/16 respectively. Fertilizer that was applied was 200 pounds per acre at 0 to 18 to 36 as far as the nutrient ratio. It was irrigated once, 7/18/16, and the herbicides that were applied were Cornerstone, AC Charger Dual before pre-plant, and Liberty plus 32 ounces of prefix was applied once. Roundup Ready soybeans received 2 applications to control the grass and broadleaf weeds, where the Liberty Link soybean was clean of grass and broadleaf weeds. They received several weeks of high winds and rain, which prevented a secondary application being needed. Therefore, pigweeds that recovered were hand pulled and removed. So this is a demonstration plot right here. Mr. Hancock told me this was a 2-year study. One side had Liberty Link, the other side had Roundup. He stated that in the Roundup side, he had more pigweeds pop up than usual. And on the Liberty Link side, he said he had little to no weeds popped up. So that can be a demonstration of how good, Liberty Link works. Some farmers will say that they'll go with Roundup Ready because, it's a better yield and Liberty Link won't have the yield that they're looking for. But in the end result, if you can keep pigweeds and larger weeds out of your plot, it adds for a better yield in the end.
Hi, my name is Shadrach Okiro, and I'm a professor in the Department of Agriculture, University of Arkansas at Pine Bluff. What I have here, I'm a cow pea breeder or southern pea breeder. And what I have today here is a demonstration of the varieties which are grown popularly and in comparison with the varieties which we have developed ourselves. We have developed 2 varieties, and here we include about four popularly grown varieties. Now, this breeding program started about 14 years ago with a purpose to provide research-based information to farmers, and also to provide research technology in form of varieties and so on. So you can really say that this is a really service-oriented and focused program. It's providing service to the small-scale farmers particularly. And we, as I said, next year we will be releasing for public production varieties which we have developed for fresh pea.
Okay, this is a study looking at the effect of cover crop in rotation with sweet potato in improving soil health and also reducing soil erosion and weed control. These studies were started about 5 years ago, and we have been able to show that inclusion of cover crop in sweet potato rotation cropping system can reduce the number of weeds, especially early in the season, where the competition with sweet potato can reduce yield. We showed also that inclusion of a legume in the rotation can reduce the money, the dollars that a farmer would spend on the fertilizer. This study here was undertaken to look at the effect of the cover crop in the rotation with sweet potato in improving the nutrient availability for the sweet potato plants. You know that when farmers grow sweet potato, they use conventional tillage. And you know that conventional tillage is going to expose the soil. When you till the soil all the time, there is an increased oxidation of organic matter, which is in the long term is going to lead to a very low organic matter content, at the same time, a very poor soil quality. So when we plant, we use a winter cover crop. That cover crop reduces erosion, capture all the nutrients that will be otherwise lost during the winter time when it's wet. And then when they are incorporated back in the soil, they are going to release the nutrients to the sweet potato plant. And we have been able to show in the previous studies that the cover crop resulted in increased yield, but compare that to no cover crop. So we took soil samples here to look at the nutrient status level early in the season. We took the soil samples again after terminating the cover crop to look how much nutrients are available for the sweet potato plant. The sweet potato plant sample that we took at around mid-season, 50 to 60 days, will give us an indication how much nutrient was used by the plant. We don't have any data to show now, but we think that the best treatment, we have about 5 cover crop, no cover crop, oat, which is a grass, a legume, crimson clover, a mustard green, which is a brassica, and a mixture of the legume with oat and a mixture of the legume with the mustard green. So we think that the oat gave us the highest amount of crop residue to incorporate back to the soil. We think that the combination of a legume and the oat, which is a grass, will be more beneficial to the sweet potato plant. But we don't have any data to support that, but that's our hypothesis. And we hope that will be also correlated with the marketable yield that we are going to obtain for the sweet potato.
So this is our sweet potato collaboration studies. And what we do here, we evaluate lines or cultivars that are released by the universities, mainly Louisiana State University and the North Carolina State University. These lines are put out every year, and we grow them out as part of the National Sweet Potato Collaborators Group yield trials that are done annually. We grow them out based on the industry standards. We apply pesticides that are usually applied within the industry. We fertilize based on exactly how the farmers would fertilize. And at the end of the trials, these lines are evaluated for yields and their responses to fertilization and pest control issues. And the data is presented at the National Sweet Potato Collaborators Group annual meeting, at which the decision is made on which lines, which varieties are viable to move forward with as commercial varieties. Now, there are some lines here, there are some varieties here that are named, like you have Orleans, you have Covington, Bonita. Those are already released and are used within the industry. Those that are numbered, like the NC 04531, the LA 134, those are the lines now being tested. And in another couple of years, after 2 or 3 years of trials, the data from these trials would be used to determine whether they are deemed commercially viable to move forward with.